Okay, since we've got some of these questions or these types of questions showing back up on the project, I wanted to make sure that we felt properly supported. I know that there can be a lot of confusion between combinations, permutations. When do we just need to use an exponent, things like that. So I'm going to run through the 8-5 activity. Hopefully, this kind of makes sense here. So we have 110 Motion City soundtrack songs. We're trying to pick 12 of them. And the big distinction between number 1 and number 2 was whether or not the order mattered. So usually that'll be kind of clear in the problem. So for this one, right, the order of the songs is important. So if order matters, we're talking about a permutation. Right, permutation. A combination is when it doesn't matter, and that's when we see in number 2, the order of the songs is irrelevant. So in number 1, right, order matters. In number 2, order doesn't matter. So that just changes which function we're going to use. So in the first one, if order matters, we're going to look at permutation, and then when we start typing, if you forget what function it is, if you're like, oh, is it per, is it perm, is it permute, is it permutation, whatever, when you start typing, right, this kind of autofills for you. And the very first one, permute, let's hit tab there, and it says, okay, number and then number chosen. So we have 110 songs and we want to choose 12 of those. Right, and this is going to give me some huge number. Remember that E is basically our scientific notation, meaning times 10 to the power. So this is 1.6848 times 10 to the 24th. So we would essentially move the decimal place 24 places to the right. So huge number. Okay, for part 2, though, order doesn't matter. So we're looking at a combination, right? And this is just combin. And we say, okay, again, 110 and 12 is what we're looking at. And this is still a huge number as well, but not quite as huge. So if we're just looking at the number of collections of 12 songs, yeah, it's a big number. But when I take each collection and then I say, well, now I can order them in a certain fashion, then that makes even more. So permutations should generally be larger than combinations as long as we're talking about the same number of items to choose from and the same number selected. Okay, so that one again is just permutation combination, no big deal. So in number 3, we have a pick 4 lottery. Now pick 4 lotteries a lot of times don't let you use 0. So many times it'll be 1 through 9. But here I said, let's use 0 through 9. The order of the numbers matters. So I gave us an example. 1, 2, 3, 4 is not the same as 4, 3, 2, 1. So first of all, order matters, sure. So that might make us think that it's a permutation. However, there's a second piece to this, which is repeats are allowed. Now, permutations do not allow for repeats, nor do combinations. So if we're talking about repeats being allowed, then really we're looking at something more exponential. So is this an example of a permutation or combination? Actually, it's neither because of those repeats. So part A would just be neither because the repeats are allowed. Right? That's my very shorthand version. Obviously, we'd want to write that as a sentence. In 3B, how many possible pick 4 numbers are there? Well, if we think about this like, okay, how many choices do I have for the first digit? Well, 0 through 9, so 10 choices. And then how many choices do I have for the second digit? Same thing, because repeats are allowed. And then we do the third digit and the fourth digit. So this is one way to do it. 10 times 10 times 10 times 10. Great. So we get 10,000. Now the other way to do this, of course, if we're repeated multiplication, we saw this in the video, we would just do 10 to the 4th, right? Which is also 10,000. Okay, in part C, we got a suspicious person. For some reason, they don't like the number 7. Okay, well, it doesn't really change a whole lot. It just means that, from those digits, 0 through 9, we're going to take out the number 7. So instead of having 10 choices, we now have 9 choices for each digit. Repeats are still allowed. So we're just going to do 9 to the 4th. We get 65, 61. And then in part D, we're going to say, okay, another suspicious person wants to play the pick 4, but avoid repeating any numbers. So we can toss out the condition in C. So 7 is back in play. We just don't want to repeat anything. So now we're saying, okay, order matters and no repeats. That sounds like a permutation, right? So we're going to say, okay, cool, equals permute. And then we're going to say, well, out of the 10 numbers that we have to choose from, the 10 digits, 0 through 9, we're going to select 4 of those. Again, no repeats when we're doing a permutation. Permutations say the order does matter. Okay, so we get 5,040. So we get about half as many options as we would have in the case where repeats are allowed, right? That was 10,000. So, and if I want to move this thing, maybe I can do that just to be a little bit more clear. And this one was no 7s. Okay, so hopefully that's a little bit more clear. I know that one kind of tripped some folks up, but it should have hopefully followed the videos pretty closely. Okay, in number 4, this one is basically just saying, figure out which of these scenarios is exponential versus permutations and combinations, right? So what do we just need exponents for? What do we need? Again, repeats allowed. When we see yes, that means permutations, combinations are out. So order matters, yes. All right, this first one is definitely going to be where we just need an exponent. So we're selecting from the numbers 1 through 44, and we are selecting 5 of those. So choosing 5 of those numbers. If it's the case in part A, the very first part of part A here, where we have order matters, repeats allowed, that means we're saying, okay, cool, we have 44 choices for the first, 44 for the second, 44 for the third, etc. So this sounds like 44 to the 5th, right, which is going to be a pretty big number. In the second row, the second empty row here for total possibilities, we say, okay, order does matter, but no, you can't have repeats. So order matters sounds like a permutation, right, with no repeats. And the first case was just using an exponent. So we're going to say, okay, equals permute of the 44 numbers, choose 5 of them. Boom, we get that. And then the last one, order doesn't matter, and you can't have repeats. So that sounds like a combination. So we're just going to do equals combination of 44 numbers, choose 5 of those, right? And this should be, again, smaller than the answer we get for permutations, because this is just saying, let me get the collections of 5 numbers. The permutation says, once you have those, now we also need to order them. Okay, for B, which scenario gives odds closest to what the government wants? So they want the odds to be about 1 in a million, right? Well, that means there should be about 1 million total possibilities, right? Only one winning set of numbers. So out of however many possibilities, the closest one to 1 million is going to be combination here. So this is going to be scenario 3, right, with our combination. And that one's just over 1 million. So that's fine, right? It's an extra 86,000 over, but that's fine. Okay. In part C, we talked about this briefly at the end of class. Basically, I gave you the formula, so you didn't have to go searching for anything. The idea was we're still using the 44 total numbers, the 5 selections, all that stuff. So N is 44, K is 5. Now, you could have done this. Certainly, you could have just said, all right, I'm going to do the factorial of N plus K minus 1. So 44 plus 5 minus 1, right? We could have done that. Divided by whatever K is, in this case that's 5, divided by the factorial of N, 44, minus 1. So sure, you could have done this. This is totally fine. Totally fine. The other thing, though, that we could have done is we could have said, well, I looked ahead a little bit. I see in part D, I'm supposed to come up with some sort of draggable formula, something that where if I change the number that I want to select and the number that I'm selecting from, I can just quickly get an answer on that. So the alternative is, instead of going in with these specific numbers, reference some sort of column for n and some sort of column for k. So if we did something like this, oops, autofill there. If we said n, actually, let me do it in the order that we have here. So we're selecting k numbers out of n, and I'm going to put total possibilities on this side since I'm putting all my answers in this column. So in this case, right, we've got 4 and 40, we've got 8 and 60, we've got 11 and 33. So the idea is, again, I don't want to go through what I did in part C here and have to type in all of this stuff over and over and over again. So I'm going to think about, you know, how would I'm going to copy that formula and say, well, how would I update this so that I can just use relative references, right, n and k. So I'm going to say, all right, where I see a 44 in my formula, really what that was I was referencing whatever n is. So I can just click on the cell representing n for this guy. So I'm going to do that in 2 different places because it's in the numerator and denominator. So there I'm going to reference n again. Anywhere that I see 5, that was basically saying, hey, that was trying to reference k. So I'm going to click on the cell referencing k. And that, again, happens in 2 places. So our formula, right, you can click up in the top here and just kind of see it more clearly, the red and the blue, what it's referencing in here. But we get blue plus red minus 1. Okay, so n plus k minus 1 for our factorial in the top, divided by the red, so divided by k, divided by the factorial of blue minus 1. Okay, n minus 1. Cool. So I hit enter. I've got this. And then now if I just drag this formula down, right, it's going to reference those other cells. Let me click up here. Yep, it's referencing those. Let me click up here. Yep, it's referencing those. So, right, I could do this if I needed to drag it down farther. I could certainly do that. But this is the general idea. And so I could have just done 4C kind of along with this table. In part E, copy and paste your formula. So whatever it looks like, I always give you just some random, you know, sort of average thing, like just to let you know, like, here's what I'm looking for. So copy paste your formula from part D. So that would basically just be, you know, this guy. For mine, the cells are kind of off to the side, whatever. But you would just copy and paste the formula itself. And so that we would say, okay, cool. If I came down here, whoops. That is a reminder, right? Anytime you are in a formula bar like this, make sure that you hit enter to get out of it, and then you can copy and paste over here. So the other thing is a little thing in Excel. If you do an apostrophe, it will keep what you have. So it will not interpret this as a formula if you do an apostrophe. It just says, I want this to look exactly as it looks. That might be helpful sometimes, like if we do the date 9/7, right, it's going to interpret it as September 7th. But if you do apostrophe 9/7, right, then it'll just say, oh, you want 9/7. So that apostrophe can be helpful. Okay, I hope that this little walkthrough helped clear up any issues that you had with today's in-class activity. I hope that it helps on the homework. I hope that it helps on the project. And just a reminder, you know, I'm always here. I'm always an email away. So if you need help, reach out.